Hello everyone, and welcome to Biopedia. The very first episode of this podcast went live on the 26th of October 2020, with the trailer going live the day before. Provided I've done all of my admin correctly, this episode is meant to go live on the 6th of April 2025, so about 4.5 years later. Why am I mentioning all of this? Well, that's because this episode is episode 100. It feels very strange to have got to this point, and sincerely, thank all of you for listening. It's crazy that so many people are interested in this. I'm sure you will agree that this is quite the milestone. To celebrate, I put up a poll on our YouTube community a good while back, asking which milestone in the world of biology you would like to see covered in this episode. It felt appropriate, a milestone for a milestone. The one which won out was germ theory. So, that's what we're going to be discussing today. To do this, we need to discuss the life of Louis Pasteur. Louis Pasteur was a man from a chemical background who became a vocal opponent of the concept of spontaneous generation. Spontaneous generation is the idea that microorganisms emerge from dead matter out of nowhere. This notion came from the fact that, for example, food seems to suddenly be thronging with microbes when it decays. Spontaneous generation had been held to for millennia. However, Louis Pasteur believed that microorganisms seen on perishable matter actually came from the air around it, or else had already been on the surface. He theorized that, should food be sterilized, it would not decay if no new microorganisms could land on it. This leads to some experiments. He employed high temperatures to kill microorganisms in a solution of nutrients. If this was sealed up, it would not decay. However, this did not satisfy those advocating for spontaneous generation. They argued that, decay needed new air, essentially pushing the goalpost further down. Pasteur's following experiment counteracted this idea. In the year 1864, he built a flask with a curved neck, called a Pasteur flask by us today. Inside this Pasteur flask, it was possible to sterilize broth by making it hot up to the boiling point. The curved neck stopped anything except air molecules getting in, including microorganisms. In other words, new air could enter, but microorganisms could not. Inside these flasks, sterility could in fact be preserved without limit. However, if other matter got in some way, such as compromising the neck of the flask, decay could be seen. This experiment, which built on the vacuum sealing type experiment we mentioned earlier, put the idea of spontaneous generation to bed, and showed, for example, how important sterility was in medicine. This brings us to the next step. Joseph Lister, a physician from the UK, worked out, off the back of Pasteur's work, that microbes were behind infections from surgery, and brought in new techniques to combat this. However, we now turn to Germany and to Robert Koch to fill in the last gap in germ theory. This is because, although the work of Lister and Pasteur had demonstrated that microbes were behind infection, germ theory did not have the backing of experimental evidence yet. While researching anthrax, Koch found that Bacillus anthracis, the causative agent of anthrax, was always in the blood of animals infected with anthrax. However, this was not cause and effect shown in itself. So, Koch did an experiment on mice. If a non-infected mouse had some blood from an infected mouse injected into it, that mouse developed anthrax. More than that, the blood of this newly infected animal could infect others. Koch then showed that the bacterium Bacillus anthracis could be cultivated outside of the bodies of mice. These cultivated bacteria also resulted in anthrax when injected into mice. Interestingly, Pasteur himself wrote about this process in the Science Journal in 1881, specifically using the blood of a chicken infected with chicken cholera. The blood was then introduced to broth which was previously sterilized. If the temperature was kept at about room temperature, microbes grew which could in turn grow in new containers. If chickens were inoculated with this organism, they died. Pasteur also observed that, if you left it longer between successive transfers, the resulting inoculation would be less fatal to the chickens. Anyway, divergence on Louis Pasteur over, back to Robert Koch. Koch developed a series of postulates based on experiments like this. The first is that the organism thought to be the causative agent of a disease should always be present when there is disease and absent when the disease is not there. The second is that it should be able to be cultured, so grown outside of organisms. The third is that cells so grown must be able to cause the disease in a healthy animal. Finally, the fourth is that, if you isolate this organism from the newly infected animal, it should be the same organism as before. So, that's germ theory covered, bringing us from spontaneous generation to experiments showing that, for example, bacteria can cause disease. As always, thank you all for listening, but thank you in particular for listening to 100 episodes of Biopedia. As I said at the start, it's been quite a ride. If you have any questions, comments, or topic suggestions for future episodes, feel free to get in touch with me at the show's email address. Until next time, have a great week, everyone.